In a New York Times article published on April 9, 1960, German rocket scientist Werner von Braun said, "Our star is one of 100 billion stars in our galaxy. Our galaxy is one of billions populating our universe. It would be the height of presumption to think that we are the only living things in that enormous immensity." So, a lot of people are very fascinated by the idea of extraterrestrial life, and the phosphine that we discovered on Venus might be the biggest sign of alien life we've ever discovered. I absolutely love space and alien life. It's something that's fascinated me for my entire life. So when the news came out about this, I researched everything I could find. So first I will discuss what phosphine is, how the scientists found it on Venus. Next I will discuss how phosphine is made on Earth and how it could be being made similarly to Earth on Venus. And finally, I will provide possible explanations for why scientists think that the phosphine isn't being made naturally like on other planets, and an explanation for how potential life forms may have gotten there. So phosphine is made up of two different atoms, phosphorus and hydrogen. Whenever elements react, they try and fill their outer orbit of electrons to keep the compound stable. So for phosphorus, that number of electrons is 8. On its own, phosphorus only has 5 electrons in its outer orbit, and hydrogen only has 1. So when phosphine is formed, the compound is made up of 1 phosphorus atom and 3 hydrogen atoms, and it's formed as a gas. So the scientists at MIT found the compound in Venus's upper atmosphere by using specialized radio telescopes. The two telescopes used were the Atacama Large Millimeter and Submillimeter Array in Chile and the James Clerk Maxwell Telescope in Hawaii. Every molecule will absorb and reflect different wavelengths and frequencies of light, which is what gives things their color. So according to the paper written by the 3 planetary scientists and published at MIT on September 14, 2020, they were able to set the telescopes to produce a graph showing the frequency of phosphine and when it was absorbed by the molecules. The results showed the graph detecting the phosphine being absorbed and not being reflected back towards the telescope, meaning that the phosphine is there and absorbing that frequency of light. So now that I've explained what phosphine is and how it was discovered, I'll discuss how phosphine is made and why its discovery on Venus is unique and a strong sign of life. In a research paper conducted by MIT and published in 2012, all of the phosphine on Earth is the byproduct of life. The organisms on Earth that produce that are microscopic and live in environments that lack oxygen. Those types of organisms that don't require oxygen are called anaerobic. So according to the Department of Earth Sciences at the University of Cambridge, the byproduct of these anaerobic organisms is phosphine, which can be found at the bottom of swamps and other places on Earth that lack oxygen, including Earth's upper atmosphere. In a research paper written by Amir Siraj and Abraham Loeb at Harvard University, microbial life is known to exist up to 250,000 feet in the air. To put that number into perspective, airplanes only fly at around 30,000 feet. So it's not out of the question to assume that if the phosphine on Venus is being produced by anaerobic microbes, then they could be living in Venus's upper atmosphere. Now that I've explained how phosphine is formed on Earth, I'll discuss why Venus is unable to produce phosphine naturally and describe how these possible microbes may have arrived to Venus. So phosphine has been detected on 2 other planets, Jupiter and Saturn. According to NASA's official website, the atmosphere of both Jupiter and Saturn are almost entirely composed of hydrogen and helium. In the deep layers of their atmospheres, the hydrogen bonds to the phosphorus because of both pressure and heat caused by the atmosphere and the intense gravity of the large planet. Because of this, the planets can produce phosphine thermodynamically. Venus, however, has 2 things holding it back from being able to produce phosphine in a similar method. Venus has a rocky surface very similar to Earth, except it doesn't have any water, and that prevents the gases from its atmosphere going deep enough to form phosphine. The pressure from Venus's atmosphere is extremely high, and so are its temperatures, so why can't it be produced that way? Well, that's because Venus only has a tiny amount of available hydrogen in its atmosphere. The amount of hydrogen in Venus's atmosphere is far less than 1%, around 0.0001 parts per billion. However, the amount of phosphine detected is much greater than the amount of hydrogen. According to an MIT paper published in September of 2020, the amount of phosphine in Venus's atmosphere is around 20 parts per billion. So the amount of phosphine on Venus is 40,000 times the amount of hydrogen, meaning it can't be produced similar ways that Jupiter and Saturn do. Because of these reasons, scientists think that anaerobic microorganisms might be producing the gas in Venus's upper atmosphere, but how did they get there? Scientists are unsure that life even exists on Venus, But we do know that microbes on Earth live up to around 250,000 feet. And according to the same paper written by Amir Siraj and Abraham Loeb at Harvard University, they also state that around 600,000 asteroids enter Earth's atmosphere and exit without being seriously heated or destroyed. It's unclear if the microbes exist high enough up to hitch a ride on an asteroid to Venus, but if they do live that far up there, that's a likely way they could have arrived to Venus's atmosphere. So, today I've discussed what phosphine is and how scientists detected it on Venus. I've also discussed how phosphine is made on Jupiter and Saturn, and how anaerobic microbes make it on Earth. Lastly, I've discussed why Venus is unable to produce phosphine similarly to Jupiter and Saturn, and how these possible microbes may have arrived to Earth. So the phosphine discovered on Venus's atmosphere is the biggest sign of extraterrestrial life we've ever discovered, but it's not conclusive. It doesn't mean that there's life there at all. It just means that phosphine is being produced in a way that we're unsure of, and that all of the evidence is pointing towards life. However, it could be being produced in a way that scientists just aren't understanding yet. They don't understand, or they're not aware of it yet. Until these possible microbes have been detected and confirmed, nobody knows for sure how the phosphine is being formed. Thank you all for listening to my speech.